Let's dive straight into an absolutely mind-blowing breakthrough in the future of clean energy storage. Seriously, imagine an electric vehicle driving a staggering 1,000 miles on just a single charge. Lithium-ion is fine for zipping around town, right? But aluminum air tech unlocks massive long-range potential. The secret sauce here is a galvanic cell. It generates power through surprisingly simple chemical reactions. At the anode, the aluminum metal literally oxidizes, releasing electrons and completely transforming into aluminum hydroxide.
And while that happens, the cathode is pulling oxygen straight from the ambient air around us.
So, balancing that out gives us incredible energy density, literally pulling reactants right out of thin air.
But how do we actually harness those electrons? Well, let's build a working model at home.
You just need these basic, earth-abundant household materials. Nothing crazy, just stuff you probably already have.
First up, we prep the components. Poke holes in ordinary aluminum foil and crush some charcoal briquettes.
Carefully roll that pierced foil around the charcoal and copper core. Just don't let the metals touch. Now pour in a saltwater electrolyte to wick through the charcoal and connect your clip leads.
Crazy enough, each of these safe, simple saltwater cups produces about 0.7 volts of electricity.
Using potassium hydroxide jumps that up to 1.2 volts, but definitely grab gloves for that. And this proves that by chaining just a few of these homemade cells, you can light an LED.
Or you could stack everything into this really compact, thin battery sandwich design using some styrofoam. It looks much more like a traditional battery, but the catch? The electrolyte dries out way faster. Unlike normal EV batteries, you don't plug these in. Spent packs are actually swapped out and recycled. Scaling this up means researchers have to tackle hurdles, like optimizing the absolute minimum voltage needed.
They also have to engineer clever ways to significantly increase oxygen flow into the cell's interior. Another big question, could a flowing electrolyte be the perfect fix to stop it from drying out?
The ultimate goal here is discovering safe, reliable, earth-abundant chemistries to completely revolutionize how we store energy.
So could that simple foil wrapped around your leftovers really power tomorrow's 1,000-mile electric vehicles? Imagine that!